Good morning everyone, I am Flaviana Capolini, a PhD student at Roma Tre University. Today I will present the assignment for the course module Social Life Cycle Assessment and Life Cycle Costing. For the analysis, I choose the Social Life Cycle Assessment conducted by Tragnone et al. The article titled Contribution of the Product Social Impact Life Cycle Assessment Database in Assessing the Risk and Opportunities of Honey Production. This study applies LCA, SLCA to the agri-food sector, focusing on a typical product from central Italy, 2050 grams of jar of orange blossom honey produced by a small family-run company located in Abruzzo. This is the summary of the content of my presentation. The aim of the study is to analyze the social risk and opportunities connected with honey production processes, including not only activities performed within the company, but also upstream and background processes along the supply chain. To achieve this, the authors used the OpenLCA software and the SLCA database, as well established tools for evaluating social input using a risk-based approach. These allow them to model a complete product system despite limited availability of primary social data. Of course, the 2015 grams jar of orange blossom honey is our functional unit. This study is structured according to Type 2 social life cycle assessment, also known as the impact pathway approach, unlike Type 1, which evaluates social performance against predefined benchmark. Type 2 aims to understand how specific activity can generate social impact. Type 3 are more focused on mechanism than reference model. For this reason, the author chose this type 2 approach, because this methodology focuses on the tracing the causal relationship between production processes and their social impact. The system boundary is defined from cradle to gate, covering every stage from hive placement to packaging of the honey. The distribution and the end-of-life phases are excluded due to the lack of data, especially regarding working hours and waste generation. The system includes both foreground processes directly related to honey production and background processes along the supply chain. For the inventory, foreground data used in the model were derived from the two previous case studies of LCA on the same company, which provided the site-specific information of material and energy input as well as working hours. Background processes were integrated using SLCA database and sectors connected to the foreground through monetary inputs and characterized using medium risk hours as the main impact unit. Data quality was evaluated through a pedigree matrix, ensuring transparency in terms of geographical relevance, time coverage, completitiveness, and technological representativeness. The assessment covered the whole four SLCA stakeholder categories: workers, local community, society, value chain actors. Each category was analyzed through multiple indicators, 74 in total, ranging from fair salary and accident rate to corruption, freedom of association, etc. While all main stakeholder categories were included in the assessment, the treatment of subcategories deserve attention. The authors did not explicitly exclude any subcategories, but in several cases the analysis was limited to the availability of and quality of data. For example, some indicators such as those related to minimum wage were marked as no data, since Italy does not have a statutory minimum wage. In PSLCA, indicators with no available data are assigned the same impact factor as low risk, which can be misleading if not properly addressed. The authors were careful to acknowledge this limitation and interpret the result with appropriate caution. Still, these highlight a general challenge in social life cycle assessment, the need for a greater specificity and granularity, especially when analyzing complex or context-sensitive systems. The results are expressed in medium risk hours, which combine the level of risk and the number of labor time involved. The 5 impact categories with the highest social risk were public sector corruption or fatal accident, fair salary, trade unionism, public expenditure on education. These risks are mostly localized in Italy, which aligns with no issue in the agriculture sector, such as informality, lack of honey production, and unfunded public services. The most impactful processes were the hive placement, super storage, and decadent. In terms of opportunity, only contribution to economic development is evaluated such as an opportunity, showing a low positive contribution. In terms of system improvements, the authors suggest several methodological advancements. First, they recommended the use of reference scale approach, such as subcategory assessment method to better calibrate the risk levels using company-specific data rather than relying exclusively on sector country average. Second, they highlight the potential value of adding new context specific indicators, especially for capturing local community impacts and positive outcomes. Finally, the authors emphasize the importance of tailoring social LCA models when products are strongly embedded in local territories, as is often the case in traditional agri-food system. This suggestion aims to increase both the accuracy and representativeness of social impact assessment. The scoring and the weighting were conducted automatically with PSLCA, as you can see in the slide. And this numeric structure allowed to the conversion of qualitative social risk to quantifiable impact expressed as medium risk hours. Although the study presents a well-structured and methodologically sound application of social life cycle assessment, it also raises, in my opinion, some important points of reflection. First of all, the use of default risk values from PSLCA is both an opportunity and a limitation. It enables broad coverage of the supply chain even when data are scarce, but it may reduce the specificity of the results, particularly in highly located context. Secondly, the lack of more developed opportunity assessment leaves the analysis slightly unbalanced. In this regard, integrating the PSLCA model with a reference scale approach such as the subcategory assessment method, as I told you before, would help to calibrate risk levels more accurately and follow for the inclusion of positive social contribution than are currently represented. Another limitation is the reproducibility of the study. Although the modeling procedures is clearly explained, the full reproduction difficult because we can have difficult to access for the foreground data and the assumption used by the authors. But in conclusion, this article makes a relevant contribution to the application of social life cycle assessment in a small-scale agri-food system. It demonstrates how risk-based tools like SLCA can help overcome common barriers in data collection, especially in sectors where social data are often not available. Before closing, I would like to sincerely thank professors for offering this course. It has been an excellent opportunity to develop my technical knowledge on social LCA and LCC, but also to develop a more critical understanding of how to analyze and communicate sustainability assessment. Thank you for your attention. Have a good day.